Squeaks and I were just playing with some blocks. You know, it may not seem like it, but the cities and towns that we live in are all built using the same rules as our little pretend village over here. It's just that the real ones are bigger. And one of our viewers, 6-year-old Hannah from the UK, wanted to know how some of the things that we build stay standing. So she sent us a really great question. Why are bridges so strong? Excellent question. Sometimes when a road or railroad track needs to go across something big like a river or a deep valley, experts called engineers design and build bridges to do that job. And bridges can be really busy. Take, for example, what's said to be the world's busiest bridge, the George Washington Bridge in New York City. Look at all those cars and trucks. It has to be pretty sturdy to carry so many people and cars. For a bridge to carry that much weight, it has to be built of special material like iron and steel. But it takes more than tough materials to make a strong bridge. So let's look at how bridges work. One very simple kind of bridge is called a beam bridge. When we say simple, we really do mean simple. A beam bridge can be just a log that you use to walk across a stream. Or put a long strip of cardboard between two short blocks. That's a beam bridge too. All bridges can hold a certain amount of weight, but what happens if we put too much weight on a beam bridge? Let's find out. It collapses. So a bridge that carries trucks and cars, which are very heavy, would have to be stronger than a bridge that carries bikes or people on foot, which are lighter. So how do we make stronger bridges? Well, over time, people have learned that certain shapes can be used to make stronger bridges. Take a look at this railroad bridge. It has to be strong because it carries trains. What shape do you see? That's right, triangles. And that's not by accident. The fact is, triangles are really strong shapes for building. If you put force on one side of a triangle, it bends. But if you put force on its point, it keeps its shape. That's because the two sides of the triangle are pushed down by the force, and the bottom gets stretched out to both sides. Each side feels the force, but none of them bends, and this makes the triangle a really sturdy and stable shape. This is why you'll see lots of triangles in bridges, both above the part that you actually travel on, called the deck, and below it. The long string of triangles that you see in a bridge is called a truss. Trusses help a bridge spread out the weight that it has to carry. But not all bridges are made of trusses. If a bridge has to cross a really wide body of water, it might be too difficult or expensive to build a truss bridge. So engineers design another kind of bridge called a suspension bridge. The Golden Gate Bridge in California is a great example of a suspension bridge. Suspension bridges work by using a force called tension. Tension is just pulling something tight. Suspension bridges are made of a deck that's hung or suspended from thick cables that stretch from one side of the bridge to the other. These cables are supported by tall towers and then are held down tightly or anchored on both ends. Suspension bridges are strong because the force on the bridge gets spread out. The weight of the cars or trains or horses, whatever's traveling across it, pulls on the cables, creating tension. Those cables then pull down on the towers and also pull on the anchors on either end of the bridge to hold up the deck. I could go on and on about all kinds of clever bridges, but basically, bridges are strong not only because they're made of strong materials, but also because of the smart designs dreamed up and planned by engineers. So thanks for asking, Hannah, and thank you for hanging out with us at SciShow Kids. See you next time.